All right, Algebra 1, this is the last lesson before Friday's test. So far we have learned how to find the prime factorization of something. We have learned how to find a GCF, how to take it out by factoring using the distributive property. We've also learned how to factor a trinomial using a sum and product chart and the guess and check method. And then yesterday we learned the difference of squares method and how to factor using that. So in this last section prior to this test, we are going to be talking about what we call perfect square trinomials. So a perfect square trinomial is actually a pattern that we learned in chapter 6. It's these two patterns right here. And so what we did in chapter 6 was we were given a problem that looked like this, and we used this pattern to find what the answer would be so that we didn't have to FOIL it out. But today we're going backwards. We're going to be given this, and we want to make it become one of those. So there are 3 questions that we have to answer with a yes in order to use the perfect square trinomial pattern. If we don't get yeses for all 3 questions, then we don't get to use the perfect square trinomial pattern. And in that case, you jump into trying either the guess and check method or sum and product chart. Okay, so sometimes this pattern doesn't work, and if it doesn't work, you try something else. So let's go over what the 3 questions are. The first question is the term a perfect square? So the very first term must be a perfect square. The second question, is the last term a perfect square? So the third and final term in your trinomial must also be a perfect square. Now here's what I want you to notice. See how the first term and the last term are always positive. Right away, if you have one that's negative back here, that's going to let you know you can't use the perfect square trinomial pattern. So your first term and your last term both have to be positive and they have to be perfect squares. The last question says, is the middle term equal to twice the answers to number 1 and number 2? I'm going to explain that in a minute when we actually work on a problem, because it's going to make a lot more sense than me trying to make this make sense right now. But once you get answers for yes for all 3 of those questions, then cha-ching, you have a perfect square trinomial and you can use the pattern to factor it. So let's just jump in. I think it'll make more sense when we go through these questions together what question 3 looks like. So here we go. Question number 1, is the first term a perfect square? Can I square something to get 25x squared? Well, I can square a 5 to get 25, and I can square x to get x squared. So I get a yes. Question number 2, is the last term a perfect square? What could I square to get 9? Well, that's pretty easy. That's a 3. So I get another yes. Question number 3. We're looking at the middle term. Now, one thing I want to point out is we're not actually looking at what its sign is. So whether it's a plus or a minus does not matter to us. We are just looking at the digits and whatever variable is there. So it says, is the middle term twice the product of the answers that you got in question number 1 and in question number 2. So can I take this 5x and this 3, can I multiply those together, which would give me 15x, and then double it? Well, if I have 15x and I double it, that turns into 30x. So yes, I did in fact get a yes for all 3 questions. So let's look for just a minute back at this pattern, because we have 2 patterns. What's the difference between those patterns? This right here. If your middle term is a plus, then you're going to use the pattern with the plus. If your middle term is a minus, then you're going to use the pattern with the minus. So here we go. What's going to go in the front? Your answer from question 1. What's going to go in the back? Your answer from question 2. What's going to go in the middle? Whatever that middle sign is. And this is your final answer. Notice you have to have the squared with it. Now look, if you were to get a test, say the test on Friday, and you don't remember these 3 questions, guess what? No big deal. You could do a sum and product chart. Let's talk about what that would look like real quick. Our sum would be 30. Our product would be 25 times 9, which is 225. You would go through all of the ways that you can multiply numbers to get 225. Now, because I already know it, I'm just going to tell you what it is. 15 times 15. It multiplies to give us 225. It adds to give us 30. Then I would put both of those numbers over the leading coefficient, which is 25. And remember, this step is the most important. It says reduce if possible. Well, both of these numbers end in 5. That means they're divisible by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. Guess what? That's the same fraction. It's going to reduce the same way. So if I were to write my answer, look where my variables are. They're in the front. So my variables are going to go in the front. So I would have 5x plus 3 times 5x plus 3, which is the same answer that we got right here. But this way, if you can recognize that it fits the criteria of those 3 questions, will be faster for some problems. If you get a problem where you have a product of 225, and if you have to write all of those ways down, that might take you a little while. Now, some of you could probably do it in your head quickly like I can, and if you can do that, that's awesome. But if not, this is also a good alternative. It's looking to see if it is a perfect square trinomial. Okay, so next one. Question number 1. Is the first term a perfect square? What could you square to get 4k squared? 2k. We get a yes. Question number 2. Is the last term a perfect square? Another yes. 11 times 11 is 121. Question number 3. Can you take what you got from question 1 and question 2? Can you multiply those together? So 2k times 11 is 22k, and then double 22k to get 44k? Yes, you can. So remember, question number 1 helps you put what's in the front of the parentheses. Question number 2 puts what's at the back of the parentheses, and your middle sign tells you what's going to go in the middle. And so we would have 2k minus 11 squared as our answer. All right, example 3, here we go. 49y squared. What could you square to get that? 7y. Good so far. 36. What could you square to get that? 6. Good so far. Next question. Can I take the 7y and the 6? Can I multiply them together? That would give me 42y. And then double it. That would equal 84y. Is that what we have? No way, Jose. So if right here, according to the directions, it says determine whether it's a perfect square trinomial. This is not a perfect square trinomial. And according to these directions, we only have to factor it if it is. And so since this one is not, we are donezo. Okay, example 4. Determine whether it's a perfect square trinomial and factor it. So we're going through those questions. So question 1, x squared would equal what squared? Question 2, 36, the last term would equal what squared? And question 3, the one in the middle. And remember, you're not paying attention to the sign right now. You're just looking at the number and the variable. Would it equal 2 times whatever answers you get from question 1 and question 2? So let's go through our questions. X squared gives us x squared. 6 squared gives us 36. If we take the x and the 6 and we multiply them together and then double it, do we get 12x? Absolutely. So it is a perfect square trinomial. So Question number 1 tells you what's going to go in the front of your parentheses. Question number 2 tells you what's going to go at the back of your parentheses. The sign in the middle tells you your sign in the middle, and then don't forget you need to have it squared. Done. Number 5. Look at number 5 carefully. What do you notice that's different? Here's what I see. This last term is negative. And remember what I told y'all. The first term and the last term both need to be positive. So is that going to be a perfect square trinomial? Nope. So not a perfect square trinomial. So according to these directions, we don't need to factor it. Okay, next one, determine whether, oh, same directions, here we go. Okay, so question number 1. Now let's first look, is the first term positive? Yes. Is the last term positive? Yes. Okay, so we can keep going. So we want to figure out if that first term is a perfect square. Question number 2, we want to figure out if the last term is a perfect square. And question number 3 is the one in the middle, twice the answers we got from question 1 and 2. So back to question 1, what could we square to get 25t squared? 5t. Question number 2, what can we square to get 36? 6. Question number 3, if we take the 5t and the 6 and we multiply and double, do we get what's in the middle? Nuh-uh. Doesn't work, because what do we get? We end up getting 5 times 6 is 30, and 30 times 2 is 60. So this is not a perfect square trinomial. Okay, number 7. Is it first one and the last one both positive? Yes. So let's try out our questions. I don't know if y'all can hear my dog have the door shut so she won't come in here and bother me, but apparently she's not too happy about that. Okay, everybody ready? What can you square to get 49v squared? 7v. What can you square to get 16? 4. Can you take your answers from question 1 and question 2, multiply and double? 4 times 7 is 28. 28 times 2 is 56. So we get a yes. So remember, the answer for question number 1 goes in the front. The answer for question number 2 goes in the back. The sign that's in the middle tells you what sign is going to go in the middle. And don't forget the squared. That's part of the pattern. All right. So next couple of examples, a little bit different. It says determine, oh no, it's not different. Sorry, I was jumping ahead and thinking about the next examples. Oh, don't listen to me at all. Okay, so first term is 49 a perfect square. Ooh, look at number 8. Let me erase what I have. Look at number 8. What do you notice about number 8? Well, what I noticed after I started writing it is that it is not written in standard form right now, is it? It's not written